So, as I have said, the topic of the day is linear programming. Linear programming method. Linear programming method. And when we talk about linear programming method, there are several things that we need to understand. You can mute yourself, Brian. There are several things that we need to understand. One of them is the definition. When we talk about linear programming, we are talking of an optimization technique. Optimization technique is a technique that is used to determine how well a scarce resource can be used to generate maximum returns. A resource is said to be scarce if what is required is more than what is available. That is when we say a resource is scarce. Now, linear programming is applicable in very many areas. You can apply it in making what we call product mix decisions. You can apply it in solving game theory problems. You can apply it in capital budgeting decisions. You can apply it in capital rationing decisions and many such other places. But for your syllabus, we will only handle some cases that involve product mix decisions. Now, product mix decisions will simply be about telling us how many units of which product should be produced, and after we do that production, how much profits do we start to get. That's what we shall be doing in our scope of coverage. The other thing that we need to know is about the assumptions. We have various assumptions that are used in linear programming, and these assumptions, they are well articulated in our notes. One of them include linearity. Linearity means that the values change in a direct proportion, and they can be able to produce a straight line when plotted. There is another one called proportionality. That means that the values are changing or are proportional. And you'll be seeing that even when we draw the graph. There's another one called additivity. That means that the values in the program can be divided and also can be added together. There is also another one called single valued expectation. Now, single valued expectation means that we have just one value. We don't have more than one. We don't have an environment of uncertainty. There is also what we call the non-negativity. Non-negativity means that the values are not negative. They are all positive. So those are some of the assumptions that we need to know. The next thing is about the steps that are followed. And I would wish to discuss the steps even as we handle a question. I think it is better explained as we handle a question. So let's get to our past papers and we look for a question that we can use to go through the steps of linear programming and whatever else that remains. And I have found this question of April 2022. Let's start there. April 2022. April 2022. April 2022. Question number 6A. 6A, Roman 2. Roman 1, first of all, says, highlight 4 requirements that must be met before the linear programming model can be applied. So what the examiner there is calling the requirements are what we have called the assumptions. So I think I've discussed several assumptions, and in your notes there are more than 5. Roman 2 says a company makes 2 products, 1 and 2. Each product requires time on 2 machines, A and B. The specifications for each product are as follows. So we are given the processing time, we are given the selling price, material and labor cost, maximum possible production and sales units, maximum time available for those hours. Now formulate a linear programming model to determine the number of product 1 and product 2, obviously units, which should be produced and sold in order to maximize total contribution for the company using the graphical method. Now, the very first step that we are supposed to take in solving linear programming, and as we go through this, we will also be checking in your notes. The very first step is called objective. You define what is your objective. Now, objective is what you want to achieve. And there are two main objectives. You can either be seeking to maximize or you can be seeking to minimize. So there are two main objectives. So when you read a question, you should be able to tell whoever is in charge of this program, are they seeking to maximize? Are they seeking to minimize? And that objective, you can also quickly get it from the question statement. I've been telling you question statement is the sentence that has the question mark. Now, if you look at that question statement towards the end, it is saying in order to do what? To maximize. So that tells you that our objective is to maximize. It is to maximize profits. And when you say this, I told you the other day when we were dealing with decision making, that you should have the general formula of getting profit. When we are in linear programming, profit is given as revenue minus variable cost, or selling price minus variable cost. And this is the one we call, in cost accounting, this is called contribution margin. It's called contribution margin. It's called contribution margin. So when you're in linear programming and you see the word profit, it is the other word for contribution margin, and it is obtained as revenue minus variable cost. The next thing that you are supposed to do, step number 2, is to identify what we call the variables. Now, the variables are the products that will be used to achieve the objective. The variables are the products. So from this question, what are the products? In this question, what are the products? There is product 1 and 2. So we have product 1 and we also have product 2. Product 1 and product 2. The next one is what we call constraints. Step number 3, you identify constraints. Now, constraints, they are resources that are present in the question. And not every resource that will qualify to be a constraint. But a resource qualifies to be a constraint if the maximum quantity available has been provided. If the maximum quantity available has been provided. So you check whose quantity has been provided. And upon check, you can see the machine hours in A. Can you see that? Yeah, there is machine hours in A. There is also machine hours in B. Machine hours in B. You can see the issue of production and sales. Although this is not a resource, but it's also production in production for A and also production for B. Not A. It is for product 1, and for product 2. We are given 30 and 50. So those are the constraints that are in that question. Those are the constraints that are in that question. Then from there, you are supposed to do the formulation. That's the fourth step. You do the formulation. And in doing the formulation, we will say, let X be equal to units of product A or product 1 produced and sold. Produced and sold. Let X to be the units of product A produced and sold, not product A, product 1. Then Y to be units of product 2 produced and sold. Produced and sold. Now at that point, we need to get to the contribution margin. Then contribution margin for product 1. Contribution margin for product 1, because the question has not given us in a direct way. You can see the selling price is 22. And the material and labor cost is 14 shillings. So that one is very direct. So tell me for 22 minus 14. We require a calc. What is the calc saying? 8. Good. Contribution margin 2. It is 48. You minus 37. 48 you minus 37, that gives you what? 11. It gives us 11. So the contribution margin is given. Now, once you get that, you now bring the objective function. The objective function. So the objective function is written like this: maximize Z. We always use letter Z when we are dealing with maximization. When we are dealing with minimization, we use letter F. So this then will be 8x plus 11y. 8x plus 11y. Now this is subject to. Subject to. We bring now the constraints that we have here. Looking at machine A, you can see 1 unit of product 1 requires 1.6, so it is 1.6x plus 1y is less than or equal to, this is 80. That is in machine A. The next one is it's good you also tell us this is machine A. That is machine A. The next one is 2.5x plus 1y is less than or equal to 100. And you tell us this is machine B. This is machine B. And then there is the issue of production. The maximum for 1 is that x can be less than or equal to 30. This is production or supply and demand. Let me call it that way. Supply and demand. Supply and demand for A or for product 1. Y is less than or equal to 50. It is also a case of what you can be able to supply and sell, produce and sell, that is supply and demand. So those are the 4 constraints that we have listed here. Then in one of the assumptions we say that there is non-negativity. So xy should be greater than or equal to 0, and this is called non-negativity. 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 So once you have formulated, the next thing now is to solve. The next thing is to solve. That is the next step. Solution using, there are two methods that you can use. You can use the simplex method or you can use the graphical method. So here we are advised to use the graphical method. So solving using graphical method. Solving using graphical method. Now, if you're using graphical method, the first step that we do is to get coordinates. That is the first thing that we do. When you're using the graph, we get coordinates. And coordinates are, you come here for this equation, this one, you say 1.6x plus 1y is equals to 80. Then you draw two lines. This is x here and this is y. That is x there. And that is y. You tell me if x is 0 in this equation, y will be what? If x is 0 in that equation, y will be what? $80. And if y is 0, x will be what? $50. Then you come and do the same thing here. 2.5x plus 1y is equals to 100. That's the same limit. So we have x and y. So if x is 0 there, y will be what? Y will be 100. And if y is 0, 40. That is how you get coordinates. Ikikuja kwa hii, this one, this means x is equal to 30. X is 30. And this one, y is 50. Y is 50. So from there now, you check the scale so that we can come and plot. The second step is to plot. When you're using the graph. And what you do, look here, you look at all these values that you have gotten. You see for x, tuko na hizi na tuko na hizi na hii. The highest of all ni, the highest for x, 50. And then for y, tuko na hizi, the highest for y is what? 100. So you see now x is 100. Sorry, y is 100 and x is 50. When you're drawing a graph, there is what we call proportionality. Proportionality means the height here should be more or less equal to the length there. Your y-axis here should be more or less equal to the x-axis. You should not give us a graph that looks like this. The whole of this is your y, and then your x. That graph is very, very out of proportion. You should also not give us a graph that the whole of this is your x, and then your y is out of proportion. That's why it is important you get to know the scale here so that you know how you shall balance. Like now that we can see this is 50 and this is 100, that is double. So if it's double, it means when we will have a space here representing 1 unit, that space here will represent 2 units. So that your 50 here will take the same distance like your 100 here. So you try to balance them as much as possible. You may not get them balancing exactly in many cases, but what you're saying is you should try to make them balance as much as possible. The other thing that you should notice is that every axis must be labeled, and these arrowheads, you put them at the end of the right, like you can see what I've done, but not kuchora line kama hii alafu unakuja kuweka arrowhead hapo katikati. It is not okay. Yeah. Similarly, this arrowhead, where it is put, it should just be very close to the last value, very close. Not that your last value imefika hapa, alafu unakuja mpaka huku unatuwekea hiyo arrowhead. Now, the whole of this part is deemed to be part of the graph, and therefore you'll be accused of being out of proportion. So, having said that, we can now seek to draw a nice graph. So this is 0, this is 20, 40, 60, 80, 100. This is y-axis. This is 10, 20, 30, 40, 50. This is x-axis. So these are units of product 1. And here we have units of product 2. So now we brought when x is 0, y is 80, and when y is 0, this is 50. So you connect them with a very straight line. That way, And you tell us this is the line 1.6x plus 1y is equals to 80. Then when y is 100, this is 40. So again, you connect them. The very straight line. And you tell us this is 2.5x plus 1y is equals to 100. Then x is 30, so 30 is here. So x is 30 and y is 50. 50 is somewhere here. Y is 50. Then these corners here, these ones, this one you can call it C, this one you call it B, this one you call it E, this one you call it F, and this one you call it G. What we do, you see these sides are saying less than, so we want the lower side. So you show that by shading this way. For this line, we shade like this. Then this one, we shade like this because we want the lower side. Even this one, we shade in a very smart way. Sasa hii imebaki, this one, it is called the feasible region. Feasible region. Now, feasible region is the region within which the constraints can be satisfied. So it's a region of solutions. So from there now, you interpret the graph, and the interpretation is telling us which is the optimal corner. Now, optimal corner is the corner that is farthest from the origin. You see, this is the origin here. So the solution is either one of all these corners, C, D, E, F, G. So you observe and tell me which corner is farthest from the origin. Which corner is farthest from the origin? Corner E or corner F? Which corner? Now, if you cannot see which one, if you cannot see, you test the corners. If you're not able to know which is which, you test the corners. So testing the corners. Now in testing the corners, when you come to test the corners, it is done like this. You have the corner here. You have coordinates. And then you have profit. You have the profit. So let's even start with corner C. Corner C nakani. Let's start with corner C. What are the coordinates of corner C? 0, 50. 0, 50. So you bring here a function to put now an objective function. It was what? 8x plus 11y. The objective function is what?
Yeah, 8x plus 11.
Yes, 8x. So it is 8 times 0 plus 11 times 50. 550. Let's go to corner D. Corner D, the coordinate zake zinaonekana vizuri. 20 and 50. That is 20 and 50. So it is going to be 8 times 20 plus 11 times 50. 11? 710. Let's go to corner E. Are the coordinates very much visible? Haisomeki vizuri sio? So kama haisomeki, hebu kwanza iache, tuende kwa F. I'll show you what to do. F, coordinates zake hata hizo hazisomeki vizuri, sio? It's not exact. Iache. Tuende kwa G. G zinasomeka, it is 30 and 0. So this will be 8 times 30 plus 11 times 0. That is how much? 240. So in case you are not able to read the coordinates vizuri, what you do, you solve the equations that make that corner simultaneous. So working for E. So working for E, E imetengenezwa na this line ya 1.6 x plus 1y is equals to 80. Alafu hapa imetengenezwa na 2.5 x plus 1y is equals to 100. So this one, it becomes very easy to solve because already y is inafanana. So when you say minus, so hapa tumebakishiwa minus 0.9 x is equals to minus 20. So tell me x should be what? It's 22.2. 22.2. And then put up on same 1.6 times 22.2. Or we can make it 22. Let's make it 22 plus y is equals to 80. So tell me y is what? 44.8. So can we make it 45? 45. So if we make it 45, kuja hapa useme this is 22 to 45. So 8 times 22 plus 11 times 45. $671. Let's do the working for F. Working for F. Now the equations that make that corner, kuna hiyo ya 1.6x plus 1y is equals to 80. Huyu mwingine is that x is 30. So if x is 30, then you proceed and say 1.6 times 30 plus y should be equal to 80. So y should be what? 32. So hii nayo itakuwa 30, 32. So 8 times 30 plus 11 times 32. 592. So with those results now, that's the shortest way. You can see now who has the highest? D. And something interesting, you see from observation, D was not looking like it is one of them. So yule alikuwa anaonekana ni E ama F. Actually, if you're not careful, you could have gone for F. You know, F hata imeshikwa na E. Yes. So that is about the testing corners. And now from there, below that, you give us the optimal solution. Optimal solution. Now the optimal solution, you should tell us product 1. We are going to make, remember product 1 was our X. It's good you connect us there. It was our X. We are going to make 20 units. Product 2, which was our Y, we are going to make 50 units. And after tumefanya hiyo kazi yote, the maximum profit we start to get is shillings 710. That's how you solve a program using a graph. Okay. I don't know whether that is enough, or we need to solve another one. We'll be very quickly now. We can solve November 2019. November 2019 is 25. November 2019, question 5B. Question 5B. So the question reads, a manufacturing firm produces two products, X and Y. The standard revenues and cost per unit of the products are given there. Packaging is a separate automated task, and the cost relates to materials and electricity. The maximum available inputs per week are limited as follows. The profit of the company could be increased by increasing the selling price. Formulate and solve the above in a programming model graphically. So the steps that we have followed in the other one, you don't have to go through all of them. You don't have to write. So this one I want to confine myself to the minimum write-ups that you require. The first thing, obviously, you must know what is the objective. What do you think is the objective? Is it to maximize or to minimize? So the objective is to do what? It is to maximize. It is to maximize profits. And profit, we have said, it is the price of revenue minus variable costs. And this is the one we have said is called contribution margin. We have said it's called contribution margin. Step number 2, tumesema, you identify what? The variables. Now, variables are the products that are in that question. So who are they? We have product X and we have product who? Y. We have product X and product Y. Step number 3. We have said it is where you get the constraints. Constraints are the resources whose quantities have been given. So can you see any resource whose maximum quantity is provided? The first one is what? There is material B, which we are given how many? So tumepewa 240 kilograms. Yes. Then there is direct labor. Direct labor, we are told it is what? 200 hours. Then there is packaging time. Packaging time, which we are told is what? 100 hours. Can you see any other that is given? Yes. After that, you now come and do the formulation. You now come and do the formulation. You now come and do the formulation. So formulation, it begins like this. Let X small be the number of units. The number of units of product X produced and sold. Produced and sold. Y small to be the number of units of product Y produced and sold. Produced and sold. Then contribution margin of X, because you're not given, you can see the selling price who June 400. Can you see that? And then the variable costs is 320. So that gives you a contribution margin of 80. Our contribution margin of Y is the selling price is 360. And the variable cost is 300. So that gives us what? 60. Subject 2. Subject 2. Oh, like our objective function. So objective function. So the objective function is to maximize Z, which is 80x plus 60y. 8x plus 60y. Now this is subject 2. Subject 2. Let's go to where you can see material. Naona 1 kg of material inauzwa pesa ngapi? 20. Na product X iko na cost ya material ya 80, si ndio? Can you see that? So 1 unit of X requires how many kilos of materials? To me, 80 divided by 20 is what? It's 4x. And the other one? For Y, it will also be 4. 4y. Now this one is less than equal to 240. This is material B. Material B. To end kwa labor, we do the same thing. Labor, you have 16 per hour. Now X are gonna 64. So those are how many hours? So 4x plus huyo mwingine akona that 2. Those are how many hours? Na hizi tumeambiwa they are 200. So this is labor hours. Labor hours. Huyu mwingine wa packaging tumeambiwa ni 24. So that is how many hours? 1x. And huyu mwingine ni 2y. Is less than or equal to what? 100. This is packaging hours or packing hours. And I told you there should always be xy greater than or equal to 0. This is non-negativity. Non-negativity. So from there now, we proceed and we say solution using graphical methods. Using graphical methods. Solution when you're using graphical method. Solution using graphical method. So in this case, we have what? We have to get the coordinates. We have to get coordinates. So coordinate, tumesema unachukua hii equation 4x plus 4y is equal to 240. Natuambia x hapa and y. Si lazima hata uchole. So when x is 0, in that equation, y will be what? 60. And when y is 0, x will be 60 also. So you come and take the next one. 4x plus 2y is equal to 200. So we have x and y. So you tell us if x is 0, y will be what? Y will be 100. And if y is 0, 50. Then uchukue huyu mwingine 1x plus 2y is equals to 100. So we have x and y. So when x is 0 there, y is what? 50. And when y is 0, x is 100. Good. So now you seek to plot. You seek to plot. Now in plotting, I have told you the first thing is to check the highest value for x. Naona x iko na hizi na hizi na hizi. The highest ni 100. Y ako na hizi na hizi na hizi. The highest is also 100. So tunachora tu, so hizo zimetoshana. So this is y-axis. I have 20, 40, 60, 80, 100. And these are units of product y. So this is 20, 40, 60, 80, 100. This is x-axis. These are units of product X. You already have known. Okay. So sasa we brought 60-60, yeah? So the first one is 60-60. This is 4x plus 4y is equal to 240. Huyo mwingine ni 50, 100. So huyu akiwa 50 ni hapa 100. So hii ni 1x plus 2y is equals to 100. Na huyu mwingine ni 50, 100. So 50 ni hapa. This is 4x plus 2y is equals to 200. So the corners are this one. You can call them A. No, don't call them A, or rather, we don't have A, but this one we call it T. You not call it B because you already have B there. And this one you call it D. And this one you call it E. Then these are the sides you do not want. So we shade. That way. So these are feasible region. These are feasible region. I don't know whether there we are very clear which corner is far away or we test. What do you think? Are you able to see clearly? It's not visible, clearly. So then we can test the corners. So testing the corners. Testing the corners. We have the corner. We have coordinates. And we have the profit. So let's start with corner A. Coordinates of A is 0, 50. 0, 50. Now profit yetu ilikuwa 80, 60, eh? So it is 80 times 0 plus 60 times 50. Eh? 3,000. We go to B. Not B, C. Do whether the corners of C are visible. It's clear. It's 40, 20. See there? No, 20, 40. Is that so? Corner C. Yangu imefika vizuri sana. Hapo inafika wapi? Haijafika? Sasa kama haijafika kwanza iache, tutasolve baadaye. Tuende kwa D. D inaonekana? Kwani mmechora aje nyinyi? Yangu inaonekana 40 20. 40 20, si ndio? Lakini kama we are in doubt, we shall solve. Corner E. Here is 0, not 0. It is 50 zeros. So it is 80 times 50 plus 60 times 0. That is 4,000. Let's have corner C. Kona C ndio tunasema it is made up of 4x plus 4y is equal to 240. Na hiyo line nyingine imepita hapo ni x plus 2y is equal to 100. So we can multiply this by 2 so that we have 4x plus 4y is equal to 240. So I'll say this one you're multiplying by 1, and this one you're multiplying by 2. So that we have 2x plus 4y is equal to 200. So sasa hii unasema minus you achieve 2x being equal to 40, and x then should be equal to 20. Then if I use this equation, nitasema 20 plus 2y is equal to 100. So tell me y is equal to what? Yes, tunaona ilikuwa sawa. Do you need to solve D or D tulisema inaonekana? Iko sawa eh? Okay. So then hapa tuseme 8 times 20 plus 60 times 40. $4,000. Then huyu mwingine ni 8 times 40 plus 60 times 20. 4,400. So this is the best. So down there now, you tell us optimal solution. Optimal solution is that product X, we are going to make 40 units. Product Y, we are going to make 20 units. And maximum profit is shillings 4,400. So that is how you solve a graphical linear program. So hiyo tumemalizana. On your own, you can try this question of May 2017. May 2017, question 3B. May 2017, question 3B. Whether we take a small break so that we come now to do the simplex. Like 10-15 minutes. Ndio tukianza simplex, tusikatize katikati. It's okay, eh? So Brian will have to log in again because I have to add this.
Okay.